Hi, all, this is my second video, and today we'll see how to calculate the power factor capacitance for a given motor. So the reason behind why we are going to calculate the power factor capacitance is to increase the efficiency of the system uh, and also to reduce the tariff, means to reduce the electricity bill. Okay, let us start. So for this I'll be considering a 100 kilowatt motor. So 100 kilowatt motor, and let us consider the factory which is having this particular 100 kilowatt motor is having 0.7 power factor. Okay, so we are going to increase the power factor from 0.7 to 0.9 power factor. Okay, so now the first thing what we have to do is, so let's calculate the IL for this particular motor at 0.7 power factor first. So that is power divided by root 3 into VL into cos phi, and VL is equal to 1100 volts. Let's consider it. So okay, now for a 100 kilowatt motor, to 10 power 3 divided by root 3 into 1100 into cos phi is 0.7. So what was the value of IL? That was divided by root 3 into 1100 into 0.7. That is 74.98 amps. 74.98 amps. So now we will calculate kVA value. So kVA value is the amount of energy that has been drawn from the transformer to run this particular 100 kilowatt motor. So for that, root 3 into what is VL? VL is 1100, and what is IL? That is 74.98. So into root 3 into 1100. That is 142.8 K. So kVA is 142.85. Okay, so this is the value of kVA, and the energy drawn at 0.7 power factor. So now we need to calculate kVAR. So to calculate kVAR, so we need to do it in terms of vector calculation. So in the previous video I was doing about triangle. This is a power triangle. So kilowatt, kVA, kVAR. So kVAR is equal to square root of kVA square minus kilowatt square. So kVAR is equal to, what is kVA here? kVA square, that is 142.85 square minus 100 square. So that is equal to 42.85 square minus 100 square, square root of answer. That is 102. That is 102. kVAR value is 102 at 0.7 power factor. So the same thing we need to calculate for 0.9 power factor. The calculation doesn't vary. 0.9 power factor. Okay, so for 0.9 power factor, we'll calculate the IL value, that is P divided by root 3 into VL cos phi. 100 kilowatt for the same motor again. Don't vary the motor. 100 kilowatt to 10 power 3. Again root 3 into 1100 into 0.9 is equal to 100 10 power 3 divided by root 3 into 1100 into 0.9. 58.3. It's something wrong, sorry. 100 divided by root 3 into 1100 into 0.9. That's 58.3. It's 58.3 amps. So next step is we need to calculate the energy drawn from the transformer, that is kVA. That is root 3 into 1100 into 58.3. That is 111. kVA value is 0.1, 111.1. Okay, so now we need to calculate kVAR value. So is equal to kVA square minus kilowatt square. What is kVA here? 0.1 square minus what is kilowatt? That is 100 kilowatt. Minus 100 square. Let's put the answer. That is 48.4 at 0.9 power factor. So in order to calculate what is the amount of the reactive power that has to be added, that means the capacitor, the power factor capacitor that has to be added for this 100 kilowatt motor, so we need to subtract kVAR at 0.7 minus kVAR at 0.9. Why do we have to do it? Because already we are getting 0.7 power factor for this particular motor, so we are increasing 0.2 power factor, like we are increasing it. So in order to do that, so what is the kVAR at 0.7 power factor? It is 102 minus 48.4. It is equal to minus 48.2, sorry, 48.4. 53.6 kVAR. The reactive power that has to be added is 53.6. So this has to be added for all the three phases evenly. That can be done in delta format. No, sorry, it should be done in a star format like this. For all the three phases, that is R, Y and B. So this is how it is added. This is the value of kVAR that we need to add to increase the power factor from 0.7 to 0.9. And because of this, we are drawing a less amount of energy from the transformer. So if you're drawing less amount of the energy from the transformer, then you'll be paying less amount of money. That means considerably less when compared to like at the 0.7 power factor. So this is how people will tell, like we are increasing the efficiency of the system by increasing the power factor. This is how it is increased. Okay, in the next video we will see about how to, this is for actually this power factor capacitance what I thought now was for continuous duty. So we'll see in the next video what is the power factor capacitance that has to be added in the starting actually. So in the starting also the motor will take higher current, you know that, right? Because the starting, while the motor is accelerating, so there is a acceleration time, like a different motor will have different acceleration time. So while the motor is accelerating, it will take higher current. So for that, how to add up capacitance, those capacitance is called short time capacitance. So we'll see how to add the short time capacitance for a given motor in the next video. Yeah, thank you.